Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify reagents A and B from the first reaction. H2O18 reacts with Na, a base context, to form NaO18H, sodium hydroxide with O18 as product A, and H2 gas as product B. So A is equal to Na18O, NaO18H. Moving on to the next step. Identify the second reaction. Ethyl acetate, CH3C, is equal to OCH2CH3, reacts with NaO18H, A, in a base-catalyzed hydrolysis, saponification. Moving on to the next step. Mechanism of saponification with labeled hydroxide. In saponification, the labeled 18O nucleophile attacks the carbonyl carbon of the ester. The acyl-oxygen bond between the carbonyl carbon and the oxygen attached to the ethyl group breaks. This means the 18O from the hydroxide ends up on the carbonyl carbon, forming the carboxylate product. The products are: the carboxylate salt CH3C is equal to O-18O acetate with 18O on the single bond oxygen, i.e., the oxygen that came from the nucleophile, but actually the carboxylate is resonance stabilized and the 18O attacks the carbonyl, so the carboxylate has one 18O. Ethanol DCH3CH2O, the leaving group retains the original ester oxygen. And for the final step, determine product C. The carboxylate formed is CH3C is equal to O-18O. Sodium salt form would be with Na+, but in the context of the reaction with NaO18H, the product C is the carboxylate anion sodium salt. However, looking at option CCH3C is equal to O-18O, this shows acetate anion where the single bond oxygen bears the 18O label. This is consistent with the 18O attacking the carbonyl carbon and the acyl-oxygen bond, CO of the ethyl ester, cleaving, leaving the 18O incorporated into the carboxylate. Why other options fail? A. CH3C is equal to O-18OH. This would be acetic acid with 18O on the hydroxyl, which would require protonation and also places 18O on the O, which is consistent structurally, but the reaction gives the sodium salt, carboxylate, not the free acid. B. CH3C18 is equal to O-OH. This would require 18O in the carbonyl position, which is not where the nucleophilic 18O ends up in direct attack. The nucleophile oxygen becomes the single bond oxygen after the tetrahedral intermediate collapses. D. CH3C is equal to O-Na+. This is the unlabeled acetate sodium salt, which does not show the 18O label at all. Option C correctly shows the acetate carboxylate anion with 18O on the single bond oxygen position, the oxygen derived from the 18O nucleophile, which is the correct product of saponification with labeled hydroxide. Therefore, the correct answer is C. Therefore, the correct answer is option C.